Next, we're going to learn how to calculate arc length in a circle. Arc length is simply part of the circumference of the circle, and if the measure of the central angle of the circle is in radians, the formula is quite simple. You take the radius of the circle times the central angle in radians, and that gives you the arc length. So taking a look at our picture, the central angle is marked in red, and in this case, it's an example of a 2 pi over 3 radian angle measure. The arc length is measured in blue. It's the arc created by the central angle. And then, of course, the radius would be from the center to a point on the circle. The other piece of information we're going to learn is how to convert a degree in decimal to degrees, minutes, seconds. So degrees are split up the same way that hours are. There are 60 minutes in a degree and 60 seconds in a minute. All right, first taking a look at that arc length formula. Our first example is pretty straightforward. Finding the measure of the arc, and the angle is in radians. So we set up our formula. The arc length is the measure of the angle in radians times the radius of the circle. So an exact value for the arc length would be 5 pi over 2 inches because it's circumference, which is like perimeter. The units are singular units as opposed to square or cubic. Our next example, the angle measure is in degrees, so we need to convert that to radians to find our arc length. So our arc length equals, in order to convert it to radians, we take the degree measure times pi over 180 and then multiplied by the radius. 120 over 80 simplifies to 2 pi over 3 times our radius of 7.5. We can get this in exact form. 2 times 7.5 would be 15, and 15 divided by 3 is 5. So we would have 5 pi centimeters for the length of our arc. We're going to apply that formula again, but this time we're going to find the angle measure knowing the arc length. So our first one, we have an arc length of 6 equals the angle measure in radians times the radius. Dividing both sides by the radius, we get 6/8 or 3/4 equals our angle in radians. For part B, notice the angle is outside our sector. So once we find the angle formed by our arc length, we'll have to subtract that from 2 pi in order to get the theta that we're looking for. So we have the arc length of 31.7 equals the radius times the angle. We'll just call it x since it is not the theta that is in the picture. Dividing both sides by 8, we get x is 3.963 rounded to the nearest thousandth. Again, in order to find theta, we have to subtract that from 2 pi, which is the total number of radians in the circle. So we'll subtract our 3.963 from 2 pi. So our theta is about 2.320, again in radians. On our final example, we're going to learn how to convert between decimal degrees and degrees, minutes, seconds. All right, if it's in decimal degrees, you take the decimal part and you multiply by 60. That will convert it to minutes. 6/10 times 60 is 36. Because we got an exact value, we can be done. We don't have any seconds on this one. So we have 135 degrees and 36 minutes. Second example, same process. Start by converting the decimal to minutes. So 0.23 times 60, which gives us 13.8. So we have 13 minutes. So now we'll convert the 8/10 that were left over to seconds by multiplying by 60 again. 8/10 times 60 is 48. So we have 48 seconds. So this would convert to 51 degrees, 13 minutes, 48 seconds. And finally, learning how to convert backwards. Our last example is in minutes and degrees, and we want to convert it to decimal form. So we have 18 minutes, and there's 60 minutes in a degree. And we have 30 seconds, and there's 3,600 seconds in a degree. So we use our calculator to convert those to decimals and add them together. Rounding to the nearest thousandth, we have 0.308. So our final answer would be 85.308 degrees. And last, we have a couple of your try questions.